In chemistry, why do we worry so much about getting the formula of things right and balancing our equations like this one here? Well, it's because these numbers, the subscripts and the large numbers in front of things, represent a thing called amount. And if we know the amount of certain things in a chemical reaction from the equation, we can make predictions or know how much to use, that sort of thing. So it actually allows us to have a better understanding of chemistry. So what is this thing amount, which by the way has a symbol N as a number of something? Well, the amount of something in chemistry is measured in a thing called mole, and I think the word mole comes from the word molecule. A mole is a really, really big number. So rather than using this really big number all the time, we have a unit for that called the mole. This number here, 6 times 10 to the power of 23, is equivalent to having a 1 in front of something in an equation, so no number in front of something in an equation. So this is 1 mole of O2, which means it's that many oxygen molecules. So you can see why we don't write 6 times 10 to the power of 23 in front of that and 1.2 times 10 to the power of 24 in front of that. We just simplify it as a mole. This number is called Avogadro's number, and it was worked out to be the number of carbon-12 atoms in 12.00 grams of carbon-12. Pretty precise sort of thing. And we do know it to more significant figures than just this, but this is as much as we need for what we're doing now. So what we need to know is, okay, if I have an equation like this, it means that 2 moles of magnesium reacts with 1 mole of oxygen gas to make 2 moles of magnesium oxide. And then within that, I need to know how many moles of every atom or ion I've got. So 2 moles of Mg means 2 moles of magnesium atoms. 1 mole of O2 actually means 2 moles of oxygen atoms because it's O2. 2 MgO means I've got 2 moles of magnesium ions and 2 moles of oxide ions, as shown down here. So in case you're wondering how 2 plus 1 could equal 2, it's not. It's actually 2 plus 2 is 4. So it still is the same number of particles on each side. They've just been rearranged, and that's what a chemical equation or chemical reaction does. We call these mole ratios, and what that means is that, hey look, we're not usually going to have 2 moles of magnesium reacting. We're going to have, let's say for example, 5 moles. Well, if there were 5 moles of this, I'd need 2.5 moles of this, and therefore, because the number's the same in front of these, it's a ratio. If I start with 5 moles of this, I'll end up with 5 moles of this. Likewise, if I had 10 moles of this, I'd need 5 moles of oxygen to react with it, and I'd make 10 moles of magnesium oxide, and so on. And that's probably the hardest bit in working with these equations, is knowing how much do I really have, what is my actual amount, number of moles, and therefore how many moles of everything else is used and made. And that's something we're going to learn to use during this week.